Okay, welcome back. Hope that went well for you. The next one we're going to look at is a little bit like the one that we worked on the other day. I want you to imagine that we've got a bead on a wire. Okay, and this thing's moving around. The movement is defined as this. Now this is its displacement function. So from that displacement function, we're going to find the velocity and the acceleration, and starting with the velocity. So velocity as a function of time is, you'll remember, the first derivative. So I've got 16, how's my alignment here? I screwed it up on the last one a bit, but my alignment's pretty good. 16t minus 4t squared. That 3 is going to cancel with that 3 in the denominator. And so that's our velocity at any given time. I'm noticing a common t and a common 4 there, but I'm just going to leave it like that. And the next is the acceleration, which from our previous discussion is v prime, the derivative of velocity, or if you want to think of that as the double derivative of displacement, you're welcome to, and that's 16 minus 8t. Okay, so that's after t seconds. Now before we move on, I just want to make a little domain restriction that says that t is positive. Okay. Now like yesterday we said that there's some information here. If we just look at this, I let t be 0 and I know that s at 0 is 0. Now that we have this here, we can see that v at 0 is also 0, and the acceleration at 0 is 16. So I'm just going to write it up here because I'm out of room. So you can see instantly we're starting from rest, we're starting from what we're calling our origin, and we're going to be accelerating at a constant rate, or at 16 at time 0. Okay. All right, next let's figure out the acceleration after 1 second. So that's just a1. 16 minus 8 times 1, 16 minus 8 just gives us 8. And our units of acceleration are meters per second squared. And then again at 4, and we have 16 minus 8 times 4, 16 minus 32. So there we've got negative 16 meters per second squared. So sometimes it's positive acceleration, sometimes it's negative acceleration. When is it switching between positive acceleration and negative acceleration? Acceleration in this direction and acceleration in this direction? Well, that would be when the acceleration is 0. So what we're going to do here is we're going to set it equal to 0, and we'll solve for t. So that means 0 equals 16 minus 8t, 8t equals 16, and then by inspection, you can see that that's t equals 2 seconds. Okay, that's the only 0 for our acceleration. So the next two questions are really similar. Oh my goodness, I did the alignment thing again. So just backing up to where you were probably yelling at me in your head. Backing up, we're going to set a of t equal to 0, solve for t. There, we did it. We see that t equals 2. Okay, and now we're going to figure out when is it positive and when is it negative. Now in order to do this, we're going to make ourselves a little table. And this is reminiscent to what we did in the pre-calc section. And we're using t2 there, and we're going to explore acceleration as a function of time. And then what I need to do is just take these two intervals. Really, we're going from t equals 0. That's our domain restriction we imposed up above there. And what we're going to do is just take some test values in each one of these intervals. Now I'm treating the top of this table like a number line, imagining that it's starting at 0 and going on in that direction. And so I'm going to try to pick some smart things. Well, we've already explored the acceleration at 1, and we said that the acceleration at 1 was 8. Now that's positive. And then the acceleration at 4 was another value that we explored up just above us here, and we said that that was negative 16, and so that's negative. Now, those are the two intervals, and so we just need to describe those. Determine the times where it's positive. Well, acceleration positive occurs when we're going from 0, and we're going to include the 0 because remember we explored it up there and said that at 0 it's 16, and then we're going to go up to 2, but we're not going to include the 2 because it's actually stopped or switching between positive and negative. And then determine where it's negative, acceleration negative, and now we just need to use the other intervals. So everywhere from 2 up to infinity, and we don't want to include either of those values. Okay, so just a quick recap. Acceleration is simply the derivative of velocity, or if you want to think of it as the second derivative of displacement, you're welcome to it. And then in these situations, on a straight line, we're going to imagine being on like a very tight wire, and this bead is just moving back and forth. And just like we did before with velocity, we can just go through and evaluate it at different points. The interesting point is when it's 0, and then that's where we can see the switching behavior. Okay, so the next thing I want you to do is I want you to try what I have prepared as the comprehension check, and I want you to individually work on that and see how it goes. And then once the comprehension check is done, then we'll get you to start working on the homework practice, and this will be your practice assignment. Okay, good luck, and we'll see you on Tuesday.